Okay, here we're going to learn a whole lot about circles. We're going to learn about their circumference, the area, the length of an arc, and the area of a sector. Now, when we talk about, let's say we were talking about a rectangle. There's my rectangle. Now, if we talk about walking around the outside, we're talking about the perimeter of it, aren't we? So we're talking about as if we walked along here, then we walked all around, and then we would call that the perimeter. But with circles, it's called the circumference. So we're talking about how to find the area of the outside of a circle. So we know that when we're dealing with circles, we're talking about pi. So our circumference, which we'll do by the letter C, is equal to 2 pi r, r being the radius. Well, we know that when we multiply, it's the commutative property, so we can change the order. So this is also equal to pi times 2 times r, and we know that twice the radius is the diameter, which leads us to the other way of writing the circumference as equal to pi times diameter. For this one, we're going to use 2 pi r, even though you could use pi times diameter. So that's the circumference. That's as if we were walking around the outside area of the circle. For the area of the circle, what we're taking is it's pi times radius squared. Now we're taking whatever that radius is and we're squaring it, multiplying by pi. Now remember, if they ever ask you for an exact answer, you always have to have pi in your answer, because we know that pi is a never-ending number and it never repeats. So if they said our radius was equal to 3, so for our circumference, our formula is twice times pi times 3. We can change the order because it's commutative, so which gives us circumference is equal to 6 pi. And if they want it exact, you have to leave it like that. And if they want area of this circle with a radius of 3, it's pi times 3 squared. So the area is equal to 9 pi. These are pretty straightforward formulas that you've seen before. But now let's talk about arcs and areas of a sector. Now let me explain the difference. An arc is something that's just going to go around the outside. Let's say I wanted this area here of the arc. Okay? The first thing you're going to have to know is, let's just make this, that's a little easy. I made it 90 degrees. We can work with that. So an arc is just the outside area, but you need to know that interior angle. And our formula for it is whatever that area is. So let's write length of an arc is going to be whatever that degree of that angle is over 360. Why? Because there's 360 degrees in the circle and you're taking part of it. Now, because we are talking about just the circumference, we're going to multiply that by our formula for circumference. Does that make it easy? So let's look at this. If we use 90 degrees, so it becomes 90 over 360 times 2 times pi, and what did I use before? Well, we'll make the radius equal to 3. I think I did that last time. So how many times does 90 go into 360? 4 times, so it becomes 1/4 times 6 pi. Simplify that to 6/4 pi, which reduces to 3/2 pi. Now, if they say round to the nearest tenth or nearest hundredth, then you would put in numbers for pi. But for right now, we're doing exact, so let's just leave it in terms of pi. That's another way that they may say it. Give your answer in terms of pi, because that way it's exact. So that's how the length of an arc. So remember, it relates right back to our circumference, and all we need is that angle, because that's what part of the circle we're talking about. So now, let's change this, and let's look at it. Let me move this radius, our circle, down. And we're going to do a little bit different. I'm going to put our formulas. I'm going to put this a formula for area of the circle, which is pi times radius squared. And let's go. Pick an area that goes something like this. Let's make this a 50-degree circle. So now I want to find the sector. Now the sector is this entire area. It is going to be everything within this little area. Although I'm not real good with this marker, you get the idea of what I'm trying to get. That's the sector. So it's going to be more of the area, so it's going to relate to our area formula. So once again, we're going to do whatever we're working with, 50 over 360. Why? Because that's our angle, 50 degrees, out of the whole circle, times our formula for area, which is pi times radius squared. Let's use 2 for a radius this time. So that gives us 5 over 36 times 2 squared, which is 4 pi. Multiplying them out, we have 20 over 36 pi. We're going to reduce that to, okay, so now we're going to take both of these and find our largest common denominator, which is 4 goes into both of them. So we have 20 divided by 4 over 36 divided by 4. 20 divided by 4 is 5. 36 divided by 4 is 9. So our answer is 5/9 pi. So remember, whether we're talking about an arc, we're talking about the circumference. It's going to relate to how big that angle is versus the whole circle, and then multiplying it by your circumference formula. If we're talking about a sector, which is a part of the area of the circle, we're talking about, once again, the part over the whole of the circle times the formula for the area. Both of them relate. Once you understand this, it starts to make a lot of sense. It's